This thing is so screwed up. Unbelievable. Why did I lose that connection? Okay, yeah. I am painstakingly... Normally I say nothing, and now I was painstakingly explaining everything. Okay. I'll summarize what happened so far, otherwise, you know. So the problem is that as long as there is no local extreme found at all, we did not decide yet on which way to go. And really I don't care even which extreme we end up in. So although I start here, and from here we decide to go downhill because you're looking for something, preferably a minimum. But this thing is a parabola with a minimum here. And thus we jump here, or was it here? The 2 is all the way over here. Just start over. So the parabola here has a minimum, yeah, all the way over here. This parabola. So we jumped past the actual, the next minimum, let's put it that way. But I can't complain because we never said we would go to the next minimum here. We just want to go to some extreme. So I'm not really saying that, you know, this has to be fixed. Plotting a cubic through these, so then makes us jump here, and then again, and then we have this cubic, and then you jump here, and now we turn out to just find this one in the S first local minimum. So that's all good. I would prefer, of course, that it did end up here, but yeah, well, we're going with this. What we're not going with is that we have an assertion now. And the assertion comes from the fact that, yeah, basically this comment. 7 too much. Oh, wait a minute, I should continue. Continue. Up 7. That's the assertion. That comes from the fact that this code says you can't have left off and right off, both. And we have that, just these arrows. But these arrows were, in fact, the range within which we were looking for a minimum, which we now found. Very much on the edge, but this is within this range, apparently. And then another thing goes wrong. It is using, as soon as we find a local extreme, like this minimum, there's a local minimum here, I'm plotting a 4th degree polynomial and then decide which way to go. And I want, of course, that 4th degree polynomial to be a very good fit for the whole neighborhood here. But it's fitting it through points 6 and 7, which are almost on top of each other, and still is using that. So there was another point that I said, well, I have to look into that. But as a result, the 4th degree polynomial does not look like this, as it should have. It looks like from plus infinity, we have first a minimum, then a maximum here, which is hardly corresponds with that maximum. And then we dive to somewhere very, 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 very negative, very far to the right, and then we have a minimum again on that side. So it's kind of bullshit. Nevertheless, then we detect that both extremes of this 4th degree polynomial are on the same side as this one, that one and that one, which means that the one that is the closest, this one, is of the opposite type. So we're in the minimum, and then we just go to the maximum here, to the closest one here, because that's the maximum. We want to go from a minimum to a maximum. So now I expect it to jump there, but it doesn't. At least that's what I said and thought. So we do the rerun again. This time my microphone works, huh? Yeah, it does. Rerun, what was the value that I was using? I forgot. Just do rerun. 16, yeah. And then continue, and then we do here. So we found 2 zeros. One at 0, one is minus 35. So that's this one, and there's another one here. And that both of them lay on the right of the point where we are now. So it's going to say, well, that the fact that we didn't decide yet which way to go, or in other words, this is the very first local extreme that we found, means that we do not do any filtering on this range, which would have been stupid anyway. This is an old range. Maybe it should already have been erased at this point, but okay, I'm not using it anyway, so let's not worry about that yet. So we just keep both zeros, and then we find out that both zeros are on the same side of the current extreme, or this is where we are. That's the local minimum that we found, and then we determine the fact that this is. I didn't save that yet. That the direction from where we are to where we go. That is to the right. And then we take the one that is the closest, which is the one at 1, which is the one at minus 35, so this one. So that means that zero's best 0 is the minus 35 one. And it's not. What frame? Oh, I didn't do that yet. Best 0. So now it is minus 35. And then I have to also initialize already here what we will do if we ever go back here and then have to explore the opposite direction, and that is going to happen. Because this is a minimum, we will find this minimum next. So we jump here and then find that minimum. Then we say, okay, this minimum is not as deep as that one, so we give up on this direction to the right. Then we go back to the best minimum so far, and we will explore the other side, with as a result that we find this maximum and then this minimum, and then there's no other maximum. Then we stop again, and then we have explored both sides of this best minimum, and that's then the answer. And that is the global minimum, so that's good. However, by the time we go from here and we jump back, we must know where to go to, and there is no fit at the moment that has a maximum. I would like to jump somewhere here, of course. This is the maximum, but the fit that we have is this 4th degree thing which is plotted through 6 and 7, which is super close, so it doesn't even see this. It thinks that this thing is going to a plus infinity. So there is no maximum, which means that I just want to do a step in that direction. And that step is then towards the left. Yeah. So we have this plot has this fit. This approximation has a scale. Don't ask. And we want to make a step with the size of that scale in that direction. And that is done. This is where we are, and then direction is to the right, which means that this is positive, but we subtract it. So then we go to the left, and that should work. As in, I can just do next here. Now we hit a breakpoint inside scale step. Okay, whatever. And then opposite direction must be set to No, minus smaller than minus 45. So we make a step of about 2 to the left. So I'm completely happy with that. Let's go to next then. I also already have to determine what the expected value is there. Well, I think that would still be pretty reasonable because it's following it here. Minus 47 is maybe here. So that's pretty close to the actual function. Not that bad. Now W is set to that 0. The W is now minus 45. We're still in that global minimum. And then we do this. And now it's minus 35. So it did indeed jump there. Here. Also set an expected value there. Which was stored in an array. I'm not really happy with the fact that I didn't filter it out. Though this is still 2, while one of them is unusable based on the fact that it is a minimum. But it's more for debug output, it seems. Otherwise, it doesn't really matter. Otherwise you would say, yeah, but why not jump here? This one is lower than that one, much lower. But okay. Next. Okay, we store those values of the opposite direction. And then if H direction is undecided, yes, still undecided, now we finally set the H direction. And that is literally just the way that we decided to go. I think this is the last measuring point. This is more or less minus 45 as well. That's probably 6 or 7. And then W is minus 35. That's what we jump to. Therefore, it is not less, so we are going to the right, which is correct. So now H direction is set to the right. We're going to the right. We are going to the right. We found this point. I don't care if I found this one or that one or even that one. We just find our first local extreme. And at that point, even though we have a super bad fit, the decision was made to go to the right, because now we're going to this maximum. And after that decision has been made, we want to set H direction. Now we're going to that direction, only that direction. It would be kind of silly to find this maximum and then go back because this one looks better. Oh, that's deeper. Let's go back. No. Now we are here. We only want to go to the right, to the right, to the right, to the right. Well, until we find a minimum that is not as deep as the one that we already found. So completely correct here. H direction is set to right. H direction to the right. Okay. Now what? Yeah, now I think here this is the point where you're going to assert. Yeah, this is that comment. So now the big question is, why this comment? We are so close. So far I didn't see anything related to this, or I mean, improvements possible, but nothing really wrong. We're just going to the right. Oh, it's using left off, yeah, but that's not good. So it's using the old left off and right off. They are just not initialized. They should have been reset. There is no left off and right off, is there? Maybe, yeah, I don't know. Well, these values have just not been initialized. That is the problem here. That is the problem. They have not been initialized. But hey, initialize range is the function that initializes them, which happens before. So what should happen is that this is called. And maybe it's just not being called, because initialize range called is already set. It's false. That's still there. Yeah, well, I don't get it. So next, now we're going to initialize them. Okay, step. Must be already decided. Yes, it is. So we set that to right. Yeah, we set both of them to end. So now they are no longer there. And now we're going to reinitialize them. We find the first sample larger than minus 45. So that's going to be, well, either 6 or 7 or 5. I don't know which one. What is this code trying to do? Get the node immediately on the left and right or of extreme W. Oh, yeah, okay. It finds 7. Yeah, 4. 4 and 7. So 4 is far away and 7 is immediately next to it, but on the right. And we're going to look for a maximum, therefore we cannot use 4 as the left off position. If we would use this one as left off, sorry, right off, then we would find that maximum. So because of this shape, we must use 7 as the right off. So right off 7. This point is right off 7. And there should be no left off, I think. Yeah, actually there is. I think in the end it must be between 3 and 2. So I think that 3 must become left off and 2 must become right off. Sorry, the other way around. 3 must be right off and 2 must be left off. Which just means that it is in between these two. Let's see if that code works. Next extreme equals maximum. Yes. Assert has minimum left node type. What was left node already set? Yes, it was set. Oh well, whatever. That doesn't fire. I wrote this code like 2 days ago, so I'm gonna assume that it works. We'll just check once we get back from it. Yep. Okay, so left off is set to I want to see right off first. So right off should be 3, 4. That's bullshit. definitely bullshit. It's like it didn't change. You just then reinitialized it. Huh? Okay, so I went through this a little bit too fast. I assumed it worked, but it clearly doesn't. We need a breakpoint here. I'm just gonna delete all breakpoints. Yes, and then break there after I return 16. Continue. H direction was set to right. The right node was 7. Now I want to check it too. Image. That is the value, and I find larger is 0733. Okay, so this one is indeed closer to the 0 than that one. And then left node must be set to probably 4, I think, or maybe 6. Okay, that's small. That's okay. And this is then 4, I suppose. Yep. Okay, no. Right node is not chain end, so we go to 1262. Next extreme type is maximum. That is the case. We're now going to look for a maximum. That means that left node must have a minimum, it says. Yeah, so left node was 4. So this is on the left of the current minimum here. Therefore, this cubic has a minimum. And it does. So that's true. In fact, this type is max min. So the cubic between 4 and 7 is an S shape, which has first a maximum and then a minimum. And the green arrow is past that minimum, even though it's like minuscule, but it is. Yeah, hello. Hello, Routine and Rajib. Next. As you notice, it was destructing. Triple 70. It's not doing any. Oh, this is just an assert. Check. Next. 80. Next. Test it again. It's still right, of course. So now next. Now I'm actually going to do some code. And well, as follows. Right off is set to this magic here. Let's see. Right off is not equal to chain end. Let's see if everything I think is correct. Yep. And then depending on it has extreme order, where the next extreme type is on the right of the other extreme type, we pick a left node or right node. Next extreme type is maximum, and the maximum is not on the right of the left node. Yeah, so we have here, this is the left node, we have the maximum and then the minimum. So the maximum is not on the right of the minimum, it's on the left. So this is going to return false, and therefore this should end up as right node. So right off must be set to right node, and right node was seven. And that is correct. So right off is set to 7. And then at the moment we return from this function, it's back to 4 again. What? So strange. Anyway, I'm going to do next. For some reason we get to see that line again. Again next. So now right off must be 7. And it's 4. Okay, well, that's wrong. So I was saying that this must be false. And it is true. Aha. So max min has the maximum on the right. No, it's not. It's just wrong. Aha. Aha. Okay, so now we can dig into this because that's definitely a bug. So has extreme order returns wrong value. Oops. Right. Crap. It returns true, so it does see that it has a maximum and a minimum. Well, not that weird because it's literally called max min. I guess I'll just have to set a breakpoint here, right? Should do that. Okay. Rerun 16. Continue. Well, let's functional again. I missed it. So okay, there's 0. So max min, maximum, right. Should return false. Now it literally says here, if this is max min, then this must become 0. B means before. So this is true if the maximum is before the minimum. It should be. And the type is max min, so that is true. So this should be true. But then we get a 2. It says that it should be min max should give a 2. Yeah, what? The comment does not fit. The comment says that it should return 0. So we do next and then print B. Gee, it's 2. The comment is wrong. I think I should exchange these, the 0 and the 2 here. Apparently. Okay, let's look at the code. I have max before min means that it has a maximum and a minimum, and the maximum comes first. And you can see in the ASCII art here what how the function looks like. So the function is just straight, or it goes up, it goes down, doesn't have a maximum, doesn't have a minimum, goes up infinitely, comes down from infinity, is flat and then goes up, so this only has a minimum, goes down and goes flat, only a minimum, only a maximum, only a maximum. This one has a maximum and a minimum, and the maximum comes first. So this one is the first one that has max before min. Here it is the other way around, so that does not have that, even though it has both a minimum and a maximum. This only has a minimum, this one has a maximum and then a minimum. So you have maximum before minimum. This has a minimum and then a maximum. This has a minimum and then a maximum. This was a maximum and then a minimum. This is only a maximum. This has a maximum before a minimum. And this is a maximum after a minimum. Sure, the bits are set correctly. At least the max before min bit is set correctly. And it should be 0, 2 to match this. And then I think my argument here was that if you have 0, 0, 0, then the result of exclusive ORs are 0. So the correct order is false if they are all 0. And if the minimum is on the left, the minimum must be on the left, I mean, then it is indeed not the correct order if the minimum is on the right. So 0, 0, 0 should return false. So this is correct, and therefore this must be a 0. These two are just wrong. It's so strange. I don't know, I'm kind of confused that I didn't run into that sooner. This should fix that assert. So now we still jump here, and then we jump there, and then we find this minimum, and then we should jump here. Yep, see, now it works. And even before that jump, we already saw this one or not? I did pay attention. Yeah. So now the initialization sets correctly the right of 3 and the left of 2. So the maximum must be in between these two, which is obviously correct, and therefore we can jump to it. And then it moves well correctly, because the maximum that the next maximum is indeed between 3 and 8. Can't complain about that. So we find 10, and indeed the next minimum is between 8 and 2, and still, and we found it. And then we jump back to 7, looking for a maximum, and now it says it must be between here and there, which are basically the only 2 points that we have here apart from that. But this is also correct. This contains that maximum, and this is the step, so the pre-calculated step in that direction, which then immediately gives us a cubic, which must be this light colored cubic. Oh yeah, we have 2 cubics. I fit cubic through 4 and 14, as well as through 14 and 7, and you see them both. And then this one is picked, of course. So we jump here, and we find the maximum there. And then we're going to look for, I'm kind of confused that this arrow that points to the left is still here and not there. Why? I mean, we're still going to the left anyway, so the minimum on the left of 15 is between this point and that point, it says. I don't see where we're going to jump to. We press space. No, it jumps here, whatever. No, the minimum is indeed between those 2 points. Between those two. Between those two. That's not optimal. Between those two, it's going to take forever this way. Holy slowly. Finally, that one is taken down. So now we get faster. I think we're there. Yeah. Now this was the very first point. There's no measuring point on the left of this. So it says, well, if there is going to be a maximum on this side, then since this is only going up, it must be on the left of that point. So we're going to, I don't know, jump there, outside. I think it stopped already, and now I have no idea what happened. Something goes wrong because it doesn't detect that now everything was, well, we are finished. We are finished. It should stop because this minimum is now explored in both directions, which I'm not storing correctly yet, apparently. And as a result, it's going to try to find the maximum again on the right of this point. And what the hell is going on here? Okay, we get an assert, rightfully, I would say. I'm not sure that ever is possible. I only get here as not implemented code when something goes wrong. I don't think we should ever get there. But okay, there's lots to improve, including, of course, detecting that we're done. And I don't know which one I shall try to tackle first. Let's make a list of what all goes wrong. So I'm going to rerun this again. Um, Nobody knows what that is. I just quit it. I think I didn't edit it from here. It just was edited in the other window. I'm gonna make a file called to do. I just can't complain that it goes here now. Hi, Mitchell. Yeah, I don't know. What does my gut tell me? In this case, we go from 3 to 4, and then we jump back to this point, which is very close to 3. That tells me that 4 isn't that very good, because apparently we want to be in this neighborhood, and now we're stuck with a point that is far away. And as a result, we approach the excellent minimum very slowly. You go from 5 is here now, and then 6. Okay, well, 6 is actually already pretty good. But it could be slow, I think. So it's better to get that 4 closer. So what I want to do is, if I see that one of the points is very far away, that I don't want to jump to the minimum, but I want to jump further, hopefully past the actual minimum, so that that new point then becomes replaces this one. And then the question is, how much further do we jump, and how far must this point be in order to do that, in the hope that we get this kind of a speed up. Now that looks like that jumping twice as far is enough, but I think if I jump 3 times further, that it won't get any slower in terms of finding the minimum. I mean, I would say instead of jumping here, we would jump 2 times as far and then 3 times as far. So then 4 would be replaced with a point here. And then of course, if you have 2 points this close to the minimum, then the next one is then bang on the minimum. So by doing that, I would have actually 5 I would still have. So it would get slower in this case, unbelievably. So here I would jump here with 0.6. We would take one more measurement. Yeah, all in all, it might speed things up. Maybe not in this case, but you see that happen here way better. So let's write this down when I see how this works. Yeah, and another thing was that is really irritating. Filter out the zeros of the wrong stream type. So when I don't know, H direction is still undecided, it just irritates me. It's also very fast, I must say. Preliminary. If this is larger than n times a minus c, then jump to a plus m times c minus a. I don't know about the n and m yet. So m is 1 normally, and then you just jump to c. But if b is too far away, then I would prefer to jump too far, so we make m larger, so that we replace b with the new point. That's the idea. So that would happen in this case again, I think. So this point is very far away, and then we just slowly approach it. Well, not slowly. It keeps being fast for some reason. Well, some reason. Maybe I understand the reason, but still. This is all of them is pretty fast, like we found, it takes a while before we find the first one, 7, but hey, only 3 samples and we have 10. 2 more samples and we have 12. That's ridiculous fast. And then 3 more samples and we have the one on the other side, 15. Actually, I think we go from 14 to 15. There's a 16 here as well. It's not really fair to call that 15. There's a 13 here as well. It's more like the 12 refers to the cubic that was used to find the minimum, but the 13 was here as well. So this is more like 3 steps here. This is 3 to the 13, and then this is 16. So 13 to 16 is again 3. So it takes like 3 samples, 2 samples in between, and then we have the next local extreme. You really can't ask more. It's as fast as possible. Very happy with this. But then, after 16, so 17, 18, and 19 should be in a minimum. But it isn't, because this is the minimum. So now we're slow. This one's really slow. Slow approach. But okay, this is a very, very, very difficult one. So, yeah, the thing here is that the jump point is super close to 18 and super close to 19. We just make hardly any progress. 20, 21, no progress made. Progress is made. And then in order to avoid that, it would be nice to make a jump so big that we just pass this point, or at least we go way faster. And I think that 3 times, increasing the step by 3 times would be really good. I mean, then either we approach it 3 times as fast, and we will probably overshoot it once, but that then will almost immediately give us the real value. So that's a good thing to do. Okay, I already wrote that down. Was there not something else that I didn't like? That suddenly is only 3 points. I thought we got more. My God, it takes so long. It's just really, really, really slow until finally, for some reason, this point is moved, and only then. Still not moved. Now it's moved, and then 1, 2, and we are there. See? So it's just important to do that way quicker. If a slow approach thing can be detected earlier, then that would be really nice. Oh yeah, of course. I have to mark every local extreme with whether or not it did already explore a certain direction. Now, at the moment we find this thing, it was already explored to the right. Which you can translate in English as that the next local minimum adjacent to this one. So not that one, I don't care about that one, only about this one, then the maximum minimum. If this minimum was found, then this one has been explored in the right direction. direction and to the right. But we must be sure somehow that they are adjacent, that there is no minimum in between it. So if 7 was not found, and we just know about, say, this point 10 and 12, then that should somehow not count as being explored. But the way this worked was we find 7 as the first one. Then we go that direction, we find adjacent 10, adjacent 12. At the moment we find adjacent 12 after an adjacent 10, which was found adjacent to 7, then these are adjacent. So therefore, at the moment we find 12, 7 is explored to the right. And then we go to the left and we find an adjacent maximum, and now we find an adjacent minimum. So at this moment, 7 is explored to the left and the right, because we found this one. But this one is also explored to the right, because, well, the adjacent works both ways. This minimum was found already, so this one is explored to that, in that direction, this point. But not yet to the left. So now we go to the left, all the way there, and then we use more energy. And now we should stop, because there is nothing on the left anymore, or at least not before we're using too much energy. So we give up on in this direction, meaning we have to mark this thing as being explored to the left. So we jump back, and then we see that it is explored to the left and to the right, and then we stop. And it is then also the best minimum. So I guess I should write down here in my to-do. Minima or extremes. So the extremes. Well, that's minima play definitely a special role there, though. But okay. Okay, I don't want to do this immediately, maybe even after that. Can start with that one. And this one is maybe complex as well, although it might be needed. Nope, I'm not sure if this is needed actually. The problem with this one is that we need to have an awareness about even a local extreme is adjacent, or did we jump past certain extremes? It should never happen. And this test has to do with that. If we find a maximum, if we make a maximum here, we find that first, then we must find the adjacent minimum. So not, the algorithm may never jump past this point then. And it's totally going to do that. So we'll find a maximum here. Then we find this parabola, which has a minimum here. So it's going to jump there. And it must reject that. Period. Based on the fact that we already found this maximum. And the reason I want to reject it then is that we predicted that the minimum would be like down here somewhere. And it turns out to be way higher. I would say that I have no clue whatsoever how to measure the deviation and exactly at which point we must reject it. If it's just a little bit higher, that would be okay. Well, I have the feeling that if we just fit an we fit a cubic between the last point here and the point here, then we will find something that has a minimum here. And then we get there. Okay, I can't even do that, right? Just start over. Yeah, this. So we jump way too far, and then we do fit a cubic. And then we find not just that there was an incredible offset here vertically to the real value of the function, but also that there is a cubic now that can be fit between the last point and the new point that has a minimum that is very far away from the minimum that we predicted. And that together must tell us that the previous prediction, that is this one, is completely wrong. And therefore we shouldn't ignore this point completely also. I mean, it's just don't jump there. As in, this will be past God knows how many minima. It's not the case that now we can jump here and then assume that the minimum that we find. What we definitely can't do is jump here and then fit a cubic between this point and that point. That point is too evil now to use. So we jump now again. Now it says let's use 2 and 3 to fit a cubic. This is wrong. This is you cannot allow this. This one should have fitted. It did. So this is sorry. This is the fit through 2 and 3, and then we have a fit through 3 and 4. 1. This one, and it should always use this one because 2 should basically be rejected as an usable point to fit a cubic through. And in this case, it does do that, so we jump here. But then again, 3 should be rejected, I think. Why? Because it's still, well, there is still a cubic that has a minimum that is very far away, like almost halfway these two. It's not very close to 3, this minimum. And there was a pretty big jump, I think. So let's see, the prediction is now here, and that's a big jump, I think. It's a big jump. So we should have rejected 3 as a valid point to fit a cubic through. And now it goes wrong, because it does pick this one. So we're fitting through 3 and 4 and then jump there. That should not happen. We should be using this one and jump back here. And then we get this point and that point. So then we get ding 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 ding, and then we get that point. Well, actually, more like ding ding ding. It's faster if I implement that to do thingy. Something like that. It's getting late, so maybe I just do the on the top now. And then I'll call it a day, I think. Filter out the zeros of the wrong extreme type. Also when age direction is still undecided. And that applies to the zeros that you find, of course. The zeros. We filter out the zeros, well, obviously. Of the 4th degree polynomial. It's not a zero at all. Actually, I should stop calling these things zeros everywhere. These are extremes. Gonna fit that too. Get more and more annoyed by it. Algorithm. Hello, Toonie. So I use the word zero. While really I should be using extreme sometimes, in most cases. Let me see, what is this? Determine the direction we must go in. This must rely on the type of the cubics rather than the sign of the derivative. Because the latter can't be trusted to be consistent. For example, it could be minus very small, which is close enough to zero that it might have ended up as less than zero due to floating point round over there. So this is not even a zero, it's just zero, the mathematical zero. And again, derivative is zero, this is just really zero. Here we talk about zeros. Okay. I already renamed this from get zeros to get roots. This does get the roots of the quotient. And the quotient is the derivative long divided by W minus extreme that we already found. So it's really the derivative. It's a part of the derivative. So if where the derivative is zero, it is indeed a zero, but then of the derivative. Sorry, well the roots of course are the zeros, it's more or less the same thing. They could still call them zeros maybe. So I call it zeros, so I make everything roots. Maybe I should just rename it to quotient roots. So I have zeros here. How many zeros do I have without a S behind it? Anything about an E? Is a zero is being passed into lambda. You have an int zero. It runs over zeros as index. Best zero, also an index. It has to be still singular of whatever I'm going to call that array, I think. Very good, that wrapped around already. So we are here. I'm gonna go look for zeros. It's all the same thing. Number of zeros, the zeros array. Number of zeros, zeros array, number of zeros, number of zeros, zeros, number of zeros. The thing is that I think of what I store in the zero is a W value. So it might be the zero of the quotient, but then at the same time, it's the local extreme of the fourth degree polynomial. So it's both an extreme and a root at the same time, depending on which function you look at. I don't want to call it okay, so I'm going to call zeros and substitute zeros with O is quotient. Do we need to know very advanced math for doing machine learning in C++? No, I don't think so, but you might call math that I find simple advanced, I don't know. For me, advanced math means that I don't understand it, so it's kind of difficult description. In that case, I would say yes. If you're in high school, then yeah, it's university level. I would call it university level. It's like multidimensional derivatives, gradient stuff, matrices, all kinds of stuff you don't learn in high school. But difficult is something else, you know. It's just another knowledge that you can pick up if you are not completely alpha person. It's clueless about computers or mathematics. My project does have recommend. Yeah, I mean I'm a fanboy of C++, of course, but there's virtually nothing in C++. All advanced stuff is being done in Python. So if you really want to do anything that other people would call machine learning, then you have to use Python, I guess. I'm more interested in research, so new stuff that nobody did yet or before. Inventing stuff, and then it doesn't really matter because it doesn't exist in Python either. And I choose C++ because I know C++. You know, if I would use Python, I don't even know Python as well, but if I would use Python for machine learning, personally, it would have given me the feeling that I wouldn't be inventing anything, and I would just reuse what other people invented for me. So like some smart guys in the world make up an algorithm, and then they write a library for it, and then the rest of the sheep are using that because the smart people made that, and that this is what everyone uses from that point on. And I don't like that. I want to make up my own shit, and maybe then go beyond those smart guys. If I just use black boxes that other people write, libraries, then I will never improve on it. And I don't know, I've reinvented a wheel like 1,000,000,000 times, especially when I was younger. I made great inventions. Never could attach my name to it because some Greek guy or Einstein already did it before me. I'm just kidding. Well, not really, actually. I did derive the relationship between gravity and time dilation. But yeah, I mean, it's always done, you know. So for now, for me, it's just fun part, and I only have fun when I at least try. I was gonna tell you, you asked about mathematics, so I was gonna show you the readme from my repository that contains some mathematics stuff. Yeah, books on my readme about back propagation. I think I figured that one out. And here there is a description, the mathematical description of how to do the back propagation, which more or less derived from scratch and wrote everything down. So if you cannot understand this, then the mathematics is advanced. But even if you know as much mathematics as I do, then it's still not an easy read. It's more like a study. So you would have to read this line by line, and you get every line you get stuck, and you spend a lot of time talking with ChatGPT and Googling stuff and thinking about it and writing small programs maybe. It's going to be really hard to get to the end. But it should be possible. And then if you do, you just have to copy this. If you get to the end, then you know what backpropagation is. But if you think it's going to come easy, no, it's not easy. Learning is never easy. But if you ask about, mathematics level, then we say, well, read that. Put 2 weeks into trying to understand it and learning anything that you don't know yet about the notation and stuff. You all have to test it out as well. I mean, I wrote this while writing programs. If you don't try it out, then you also will not be able to grasp it really. Not for real, You just, that's also why I'm coding this. If I just get a book and I read the book, and do I understand it then? I understand things so much better if I write a program that does it. And I see all the ins and outs. And I see it happening. And a moment ago you said you knew both. Let me reread that again. Did I read you wrong? No, yeah. You said, do you recommend doing it in C++ or Python? Because I know both. Scroll down. I'm very interested in this stuff, but I need to learn C++ first. Inconsistent. Toro. No, let's do the to-do thing. Yeah, I was going to do this one here. Filter out extremes. Okay, so find that. This top. Kill this program. Said kill it. Kill. Are you sure? Are you really sure? Okay, I understand that you are sure, but I disagree. I don't think you should. Are you going to force me? Yes. Sorry, Dave, I cannot allow that. Yeah, we got out of it. Okay, what next? Replaced writing debug output and sending an event to the event server directly after setting H direction with a single function. So it's then called from a lot of places. Started to feel like code duplication. And then here we renamed zeros to quotient roots. Yeah, and I'm still calling this 0. It's probably that it should be a quotient root or something without S. Or just root. Let's look at that file again. Well, there was just a bulk search and replace, so that cannot have gone wrong. I think I can just skip all that. Extra comment, more comments, and some replacement stuff. Well, I worked on that one, so that it should work now. So it's what I want to commit. So another call to set H instruction, and again, and then we don't have to send a trigger there anymore. And then that is set function. That was a bug. And here we have okay, yeah, I remember that. I said it before, like months ago once, that I'm not so fast here, I'm actually looking, but sometimes I scroll very fast through a diff like this. Oh yeah, my memory is degrading like crazy. I think I'm really going to Alzheimer situations there, but just a year ago or so I was doing this, and then I go very fast through these diffs. And then I said that I wasn't even reading the code. It's more like pattern recognition. So I come here and then I see this diagonally, and then I remember that I wrote it. So I'm not like, what is this doing? Is this comment correct? Is this formula correct? What is it doing? Do I want to commit this? No, I see this function and I remember like instantly, oh yes, I worked on that. And it felt like it is finished, you know. So I kind of remembered what I felt when I wrote it. So because it looks familiar and it gives me a feeling like that I finished that. This is so, yeah. You don't have to really look at it. Just like oh yeah, the direction trend thing, and it was good. I already looked at it and it was good. So now I don't have to look at it again. I can just scroll over it. And on this, of course, as well, I see this, I know what it is. I don't have to think in words, I just know what it is. I could decide to change it back, actually. This is a part of the test suite, so maybe before I commit, I want to run the full test suite again, but yeah, well, whatever, you know. It's not like this is the end product. I'll test it again someday. I do need to know, however, where my quotient roots went. Which file I've got. Quotient roots, obviously algorithm. And then I had 0 in there. And I wanted to probably should just get rid of the whole 0 thing, right? So we have two zeros here, yeah? An integer 0 and a double 0. So I think I'm going to call this one root. So the singular of quotient roots, but then without a quotient. And this, yeah, is really an index, but maybe I keep calling it 0. Quotient root index. Oh, how about that? Actually going to do it. It sounds so long, but hey, it is a quotient root index. Maybe you can argue that it is a quotient roots index. But it being a single index, it refers to a single root. In most cases, I would not use the index here, by the way. I would just, you know, index or not. In the end, it refers to a quotient root, so just call it quotient root, even though it's here just an index. But yeah, I don't know, I have a double root as well. Too close together. It's not all set in stone. Best 0. Now here we do the same thing again, so this must be definitely the same name, because it's really the exact same meaning as the other one. So it's the loop from 0 to the number of quotient roots. So if I use quotient root index there, then I have to use it here as well. And then we have best 0 left. That's also an index. So I could call it the best blah blah blah. But what shall we call this? It's an index, and using it as an index in the quotients roots array, that gives me a W value that then I'm interpreting as a local extreme, of an approximation of the local extreme of a fourth degree polynomial. And then it is the root of the derivative of that. Oh yeah, in the text I call it local extreme. I think I should call it local extreme. At some point we just switch. Damn it. So I switch here from talking about the zeros or the roots of the quotient, which is the derivative divided by one of, well, w minus one of the roots, to best local extreme. Well, we're really talking about the fourth degree polynomial. I'm just going to call it extreme, really. It's local, but yeah, hello, the thing goes to infinity. Everyone knows that. I'm not sure though. How would you call that? Let's ask ChatGPT. ChatGPT is better in English. Knows questions like that. So I'm saying every fourth degree polynomial goes to plus or minus infinity. As a result, can one say, or can one not say? If I just ask one of them, then it wants to please me. So I give it both options. That a fourth degree polynomial has or doesn't have a global extreme. The answer to this should obviously be that it doesn't have a global extreme, but okay, let's warm up. Yeah, it's right. I made a mistake there. Okay, let's talk about the case where a is larger than 0. So then it goes to plus infinity. Then can we talk about a global maximum for the point with derivative 0 and second derivative what is that, negative, I guess, yeah, less than 0. Okay, so it kind of agrees with me that there's no global maximum. He calls it local maximum. So what is the right word to refer to the local or global maxima and minima without including the inflection point where the derivative is not 0. So you can just leave away local. As long as you don't call it global, it's okay, apparently. Extremum. We learned something new, and the word is extremum. Includes both local and global maxima and minima. This is exactly what we wanted. I have no idea what I did. Work in progress is always good. If you work as the only one working on the project, I would argue. Well, yeah, it saves time. Let's put it that way. So now onto the to-do thing. Filter out extremes. Uh-oh. Plural extrema. Test. But these are more or less official. Should rename that. Very unlikely, but yes, extremes. But we can also rename that. Okay, start to believe it. Just replace everything. So I need a derivative then, the second derivative, to determine if it is a maximum or a minimum. extremum type. How many extremes do I have left? Shitloads. No, yeah. It's not that bad of a word. The second derivative is larger than 0. The function is concave up at that point, indicating a minimum. Minimum is larger than 0. And then at that point would be quotient roots at the quotient root index. The second derivative of this quotient root is larger than 0, then that is a minimum. And if it is not the one that we are after, then I move it. And then I did that after this assert, but the result is that now the assert is no longer true. We might now have just one root instead of two. So what is the result of that? This just loops, that's okay. After this loop, number of quotient roots equals 1. Then we only got here once. That's the other filter, but it's no longer true. Let me see. So we would never override this value. That's what it says. Because if we get here twice, then we might decrement this thing twice, and the maximum value is 2. So if we get here more than once, then we can get here at most twice, because this is at most twice. And in that case, it will end up 0, so that we're not using anything anyway. So then it doesn't matter that we overrode it. Something like that. But now it's possible that it is already decremented here, therefore it could be 1 already here, and then if we don't get here, or we don't get here, in other words, if this is not assigned at all, it still can be equal to 1. And before that it was not possible. This is just debug output. Well, if it is still 2, then nothing changed, so I suppose you can skip over this. But the else then means there is only one usable root, which we don't simply use. And the reason that there's only one, because we only got here when they were larger than 0, and if it is not 2, then it must be 1. So it's mostly about the opposite side. This and that one, of course. So opposite direction. W and LW are set at the same time here. Okay. Yeah, this is filtering out something because it's on the wrong side. That's what this thing is doing. And then we need to store it. If it's filtered out because it's the wrong maximum, the wrong type, I mean, then we definitely don't want to jump to it, which is exactly why it should have been filtered out already. So it's actually a good thing that it is not set then. However, then we still need to set it. We have to set something. I don't think that happens now. This should not happen anymore. Never. This is where it goes wrong. This is no longer true. It's getting too late. This is not easy. implement. But I'm going to bed, I think. Let me lose a game of chess first. Before I go to bed and stuff. That is not theory. Well, I think taking the knight is theory, but yeah. I don't care. You can take my pawn. Now he's kind of forced to exchange queens and then forced to take my knight, and then I have a better pawn position. Well, not a little bit. Unless I take, of course. Uh-oh. No, seriously. I can just... okay, they can exchange knight as well. They have to make my pawn position a little bit worse. How's the development? Development is not that bad. Yeah, true. This is a weak point. So I would like to play this pawn to block this bishop and not make it a weak point anymore. Also want to block this one. Is it possible to just move here, block this pawn, attack that one? If it takes here, then I just push this pawn. They can't exchange anything, and I'm threatening to nothing, really. I'm not threatening anything. Well, I'm trying to put my king here. Even... well, yeah, no, I don't want to, nah, I don't know. Probably not a good idea. Although everything's defended. Where does this knight go to give a check with the bishop, and then I take here, and then the knight must be doing something devastating, but I wouldn't know what. So push this pawn, and then they have to play the knight immediately, it seems, in order to stop me from reaching the bishop here. And then I can just put my bishop here. After which I can collect this bishop. I don't see the problem really. I think I'm going to do it. So I think I'll take the pawn there. I'm just going to have to give up the bishop for 2 pawns, which is not that bad. But on the other hand, the queen is gone. So it's material. And I hope to survive. But my next choice is probably going to push this pawn anyway. Or take the bishop, of course, if he doesn't move it. Bishop could go here. Can it? No, I want to have these pawns like this anyway. I think. So, not a good idea. Has to go back and I take it. Which is an even worse pawn structure for black. And then this one must be developed. It just has to be developed. Where shall I go? This would be a nice point. Maybe I should just push this pawn and then put the bishop there, attacking this. So I push it, they develop a rook, for example. And then I can go here. They can't attack it because this is defended. I have all those squares. They could put the rook here. No, but the pawn is there. Oh, pawn, bishop, 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 king and rook. The whole thing is my file anyway. Who cares that there's a rook here? The knight could attack it, but it's defended. This one would be pinned, so they kind of have to move the king here then to defend that pawn. I think I'm okay with this. Oh, and I completely missed that move. Oh, that's so bad, so bad, so bad, so bad, so bad, so bad. Even worse. Oh, so bad. Oh, so bad, so bad. I can't play chess at all. Really, really, really can't play chess, can I? Still, I'm going to win though. But yeah. Oh, I fucked up. How could I not see this rook and then immediately afterwards give away quality? This is too sad for words. Way, way, way too sad for words. This is also sad for my opponent. Gives back the quality. Gives back a full rook. Resigns. Resigns in despair. Yeah, dude, I want to play you again. Let's see more of those resigns. Especially more of the despair. He didn't want to play. Can't blame him. I would have gone to bed too if I lost that bet. That is my favorite opening. I started with a theory that from 20, 30, 40 years ago, which is bad. It's just totally bad. But nobody knows how to play it. Huh? What is this? I don't think it matters much. Just continue with the same thing. Develop this bishop. If now I take, I take. I have to take like that. Then I attack this pawn maybe. I think I'll take like this. It's a double pawn anyway. They threaten to push maybe. They totally threaten to push. That sucks. No, I don't see my advantage. Not seeing any advantage. They're totally going to push this. I could do this. Bishop pins my knight. My castle, they take here, winning a pawn. But then they exchange queens and then take it anyway with my knight. Or they would have to take my knight first, and I take back with the queen, and then they can take this free pawn, followed by a mate in one. So, I don't know, looks like good. Looks like a good move. And he pushes it. Okay. Looks like I can take it again. Then the bishop just comes here. So the bishop goes back. Let's say the bishop goes here, and I push this pawn. I'm threatening to take it. I can't defend it. The bishop has to go back, or he would take here, and then I take. But I'm still threatening to take it. That would be annoying for this guy. He would have to take like that. I take back, threaten mate again. Would be good for my development, I have to admit that. That's totally the case. So if we go back and the bishop goes here immediately, assuming the c4 move, then what? Then I castle, blah blah blah. I think this is not really a developing move, so I think I'm gonna do this. So, and then he does go there, and then I play here without recalculating everything again. So now I lose because I should have calculated it again. But we just rely on the previous calculations. Attacking the center, as they say. I think I could attack my pawn with the knight, but then he gives up this pawn. I just take it. Take here. Knight takes. That's no good for me. Pin the knight. Knight is to be defended, and then I can continue taking. There's a check here as well. I wish I had castled already. Yeah, well, not much options. If this doesn't work, then I was already lost. I'm blocking this now, so I'm not threatening to take the pawn. It's kind of annoying. Yeah. Can make a double pawn here now. I have to take that. But I can castle long. There's nothing wrong with this. Absolutely nothing. I'm going to win a pawn. And they either can't... Oh, what is this? Not winning a pawn. Surely I'm winning a pawn. I could just castle long, and then if they take this pawn, I take that pawn. Still equal? Take, double pawn. Isolated double pawn here. No, I don't want to do that. I already have the one here. Castle short is also an option. So I could put the rook here, make that knight look silly, maybe. Maybe. You can attack it again. Okay, I'm gonna do this. Let's say it's looking very sad. But why not castle short? Or maybe just stay in the center. I have a nice open file here. Put Baruch here. Ta-da! Castle short, he does not. want to castle short. Can I force him to? Looks like I can force him to. I don't know, this queen move didn't do anything, did it? That gonna mean like absolutely nothing. If we go here now to threaten to take this, then the knight can come here, threatening a fork. I just have to castle. And then that guy also castles, and I don't have any time left anymore. Shit. Pretty bad this. Yeah. They castled. Okay, let's defend that pawn. Probably should play this one, so I can move my queen again, damn it. With that the knight coming there. Or put the bishop here. It's probably also a threat enough. To make the beast... Oh no, it takes a pawn then. Yeah. Rook here. King here. So weak diagonal. He's going away all by himself. Okay, that's good. So let's move the king. No, he's going to after that one. I'm so losing on time. I have to move really fast. I'm going to have to move really fast. It is within 3 seconds. Every move. This guy doesn't know it yet, but he's going to lose on time. See, that knight is dominated by my bishop. They do not have any attack. And I'm going to win. Oh, wait a minute. Well, that cost me a bishop, but let's not complain just yet. Dude, just push the bloody pawn. Yeah, what else? Yeah, that was not good. Definitely not good. Rook here takes everything. Takes that one. Okay, let's go there. As if I can defend it. The only chance I have is a win on time, which is difficult. Give away pawns and grab your own pawns is the right thing to do here. Resign. Shit. Okay. Shocking. How long is that possible? Already this move. Already this move. Check, okay. Kept it out. Yeah, I could not do that. I had to play this pawn or something first. Guess I'm really bad in this position. -4, yeah. What about before I gave away my piece? Yeah, here it wasn't bad. The queen exchanges were really bad. Exchange queens would have the exchange queens forcing exchange queens, but then my rook leaves this file, so then I have to give my bishop on the pawn, so it's just really bad. Really bad. I should just attack the pawn. It's already attacked. I don't like this move. You can check and then I have to move it back. Is that the way to go for a draw? Could win a pawn here. No. Oh, make this pawn free. So we take here, yeah, why not? What is then the problem with this? Surely I can't do this. It just takes it. The hell? Yeah, what? Plus 4.6 with this move. It just takes it. Huh? Okay, what I'm not seeing. Take and then I take. Oh, it's check. Oh, I thought I would lose my queen, but no. It's check, and yeah, he has to take back like that, and oh yeah, okay, now I believe that is mate. Oh yeah, so I can't take it, yeah, and then this is a good position, of course. Yeah. So, okay, other attempt, he tries to promote, I have to block that. Now I'm going to promote to make a hole. Apparently I'm not going to promote. Okay, why is it a bad move? Very bad move. Now he can take it. Of course now he can take it. Because I'm not having a discovered attack on the rook. Oh, this is a good position to ask my pupils. To put them on the wrong leg, saying the rook pins my bishop. Can I defend it with a pawn? But if you turn it around, if he takes it, it's a discovered attack on the rook instead of the other way around, because he takes a check. Fun. So tactics that I should have seen. Now, of course, he can take. Goes all the way back. Why would I not take it? It's also a bad move, of course. Because of infinite check, or because I'm just doomed in other ways after that. Let's say take it, mate in one. Check, infinite check. Yeah, duh. Made in one. Okay, this is the end. I stopped playing chess forever. Oh, that's really bad. It's made in one. So why would he even want to defend? It's not defending the pawn, is he? Not defending the pawn. There's other plans, but apparently this is a good one. And then we try to promote, and then we get this knight here, and then we take it, and then the queen goes back. It's better than the rook forward, maybe. I'm in check, and I lose my free pawn. Nobody's happy. Still can't take it because of the check here. But we can get rid of that horrible queen. We should be able to win this pawn now, right? Takes 2 of my pawns, so defend 1. Cuts off my king, but I win the other one, so that doesn't matter. Then he gives away this pawn. Nobody gets it. Oh, because he immediately wins back a pawn. Okay. Defend 1, takes 1, defend the other. I do not defend the other. I go after the other pawn. I guess no, just take it. Take this one. They should be better for white, huh? 2 pawns on different edges. This is also a free pawn. I'm losing this pawn. Oh, no, I couldn't get a check and then go here. Why would I push this pawn? Why? King, everything, every move is draw, and I don't see how. This is such a weird waste of a move. Let's go for taking it again. And then he wants to push it again. Sure, so take it again. No, I want to take it again. I'm just gonna take it from here. Oh, then he defends it. Okay, take it from here. Now it makes sense, he says, to go here and then there. Of course, this pawn. Oh, yeah, and if I only come to remember that kind of tricks. So you can give check and then go here. So it does make sense. So just push all the way here and then do that. Then the other option was king here. And just give the pawn away. Why? And now we walk. Keeps moving the rook. Why does he keep moving the rook? I would try to promote. Let's try to promote too. This is not a losing move. And black wins. I can even go here. Get a queen to check. And this also loses. Made in 2018. Yeah, discovered a deck afterwards. Not good. Okay, so we have to take it. It is losing. No. Just not. Then you have to do that. Nobody gets a check. I just come closer here. Why do you want to give check? And I would go here, losing the game on the spot. No, I still draw. Yep, I think you have to train chess for many hours a day. These kinds of positions, play them over and over and over and over and over and over and over until you finally start to get it. And it helps if you have an absolute perfect memory, so that you don't forget anything. And you still have to play billions of games, but yeah, if you start to forget games again, then it doesn't all help you very much. White is out of theory. Never saw Sicilian before. Or his mom is calling. And he had to answer. Yeah, mom, I'll be right there. Has to go to dinner probably. Or just a player that is so slow that they're going to lose on time, like big time. Big time. Even here they think like 30 seconds per move. The previous game was a 1.5 hour per person per game. And they just forgot that this one isn't, I think. Or they are using a computer and the computer is just this set to this slow. Slow. Really, someone is this slow. Every move in the opening. How is that even possible? But they could still push the ball. Nothing wrong with pushing the ball. Yeah, in that case I'll just take it. What? Yeah, okay. Good night.